Good evening. What we're going to discuss in this video is compiler design related to the basis of compiler. Myself, Sharmila, Assistant Professor in the Department of Computer Science in the R.M.D.E. Engineering College. In the last video, what we have discussed is what is compilation, what is interpretation. I hope so you understand well what is computation and what is compilation and what is interpretation. Next, we have discussed about a small example like what is token, what is syntax, what are the different phases of compiler. These are the phases of compilation, that is what is lexical analyzer, what is syntax analyzer, what is semantic analyzer, what is intermediate code, what is a code optimizer, and what is a code generator, what is a finally the output of the program is system understanding, that is machine level language program. In that, symbol table is to store the different tokens, and error handler is used to identify the errors. These are the phases of compiler we have discussed. Before going inside that phases of compiler, you should know what is the syntax tree. Correct. Already we have discussed with one example in the last video. What is the syntax tree? How to draw is in the syntax of the programming language describes its two forms. One is organization of token. Next one is context-free grammar. In that context-free grammar, we're going to discuss about what is parsing, what is LL and LR parser. Here, in the context-free grammar, there is a notation called as CFG. CFG means context-free grammar. In that, we have an expression, we have an identifier, we have a number, we have a different symbol operators. For example, left-hand side operator consists of right-hand side is plus, minus, multiplication with sum. Using the sum identifier combination, we'll write context-free grammar. In the terminal, non-terminal, and what is the production rules, we're going to discuss. What is a terminal and what is a non-terminal symbol, and what is a production rule and how it generates the production rule in the context-free grammar. We'll discuss in the next further coming video problem. What is a context-free grammar, how to write the non-terminal, terminal, and what is the production rule. That rule is nothing but what we're going to do, set of operation that we write as a rule. And then small letter symbol, capital letter symbol, what the small letter indicates, what the capital letter indicates, what are the different operators plays a role. Like that, we'll discuss while doing the sum context-free grammar. Then what is the parsing and arbitrary context-free grammar? That is, notation is O of n of 3. That is too slow for the large programs. That is a complexity in the parsing. And the linear time parsing, there is a two things. One is LL parser and LR parser. LL parser is a left to right, leftmost derivation, and that is called as LRL grammar. It uses a top-down strategy. LR parser is left to right, rightmost derivation. Small difference is there. That second letter L represent leftmost. The second letter here that is represent or represent rightmost derivation. In the rightmost derivation, we recognize LR grammar that we use a bottom-up strategy. The two linear time passing is LL, LR. LL is nothing but left to right, leftmost derivation. LR is nothing but left to right, rightmost derivation. LL is top-down strategy. LR is bottom-up strategy. For that, we're going to discuss a small example using the comma-separated list of different identifiers. We're going to do a small derivation. This is called example for top-down derivation. Here, the context-free grammar is ID tends to ID. Then ID list tends to comma ID list, and the ID tends to semicolon. So given grammar A comma B comma C colon. For that, we are going to draw how to draw a top-down derivation. That this ID list tends to two things. One is ID, another one is ID list tail. So two things we can move. In that, again, in that ID list, for this ID list, we can write ID of A. And then for this ID list tail, we have option called comma ID list. So we are writing comma ID list tail. For this, we are substituting from top to down. So see here, you understand, I hope so, top to down. That is called as top-down approach. So it is called as left to right, leftmost derivation. That is called as LL of passing. From the left hand side only, we are substituting the derivation values. That is the example for top-down derivation. So I hope you understand. So for this, we have substituted this value, and for this, we have substituted this value. Finally, for this, we have substituted this comma using this grammar, this context-free grammar. We have substituted A, comma, B, comma, C, colon. Okay, A, comma, B, comma, C, colon. So for this expression, we have done a top-down derivation. Next one is example for bottom-up passing. Here the same grammar we have taken. Here it is called as left to right, rightmost derivation. So what is the rightmost derivation? LD of A I am substituting because I need to get the first character is A. I need to get comma. Next I need to get B. Next I need to get comma. Next I need to get finally semicolon. For that I am applying from bottom to top approach. From bottom, I am applying from to the bottom to top. That is shift reduce parser. So how to apply? ID of A, comma, ID of B, comma, ID of list tail. So comma, IDC, ID list, comma. So we are applying from where? Bottom to top. So this is an example for bottom-up approach. The LR passing versus LL passing is, its LR is top-down, LR is bottom-up. We can predict need production based on the current leftmost non-terminal in the tree, current input token, top of the stack contains leftmost non-terminal. The stack contains record what that processor expect to see. But in the LR of parser, shift reduce parser, that is bottom up, shift tokens onto the stack until it recognizes the right hand side, then reduce those tokens to the left hand side. The stack contains a record of what the parser has already seen. So here they have given hierarchy for the linear parser. The linear parser in the context-free grammar is LR of passing. Inside that is LLR of passing. We are only using a subset for all the context-free grammar can be recognized by LL of parser. This is the Chomsky hierarchy grammar. First type 0, type 1, type 2, type 3. There is 4 types of grammar. Regular grammar, context-free grammar, context-sensitive grammar, unrestricted grammar. This is a Chomsky hierarchical grammar, type 0, type 1, type 2, type 3. So in this video, what we have discussed is what is LLR of passing, what is LL of passing, that is leftmost derivation and rightmost derivation. With a small example, we have discussed what is context-free grammar. Thank you.